Hi everyone, welcome to Real Science Challenge. I'm Kent Louie, science teacher and talking head, talking about science education and broadcasting from beautiful Vancouver, Canada. This is episode 81. And today I want to share how I got ChatGPT to make a STEM project even more challenging. And since it was more challenging, there was more learning to be done. Now recently, I gave my students the aluminum foil boat challenge. You know, it's the one where students take aluminum foil, create a boat that floats, and try to stack a whole bunch of pennies in it before it sinks. Now, it can be a bit of a simple activity since kids tend to create any raft, stack a whole bunch of pennies and marbles inside, and then be done with it. Now, students often don't go through the rounds of designing prototypes and testing them, which is where all the learning happens. And this is what I wanted my students to do. So what I did was I asked ChatGPT to help me create a stronger challenge that requires students to build and test. Now, more often than not, we see AI as a means of getting an answer to a question. But this time, I was getting AI to make the answer even more difficult to get to. And the results were great. For example, one student came up with this design, a little bit of pointed end. Another student came up with this design. They have these little barriers here, which I'll talk about in a second. Both of them worked well in their own ways, and I'll tell you about the results in a second. But before I do that, handouts for this episode are available at realsciencechallenge.com/EP81. And please subscribe to our YouTube channel, and please share our resources and episodes with your colleagues. I'd love to get 1,000 subscribers by Christmas. So, like I said, students tend not to do prototypes. They tend to just take the foil, make a boat, and then check it off their list. What I did was I made 3 adjustments to my project to make sure that students built and tested prototypes. Number 1, I asked ChatGPT this question: how do I make the aluminum foil boat challenge more challenging? Then I used ChatGPT's suggestions and I put it into the build criteria for students to follow. I also gave, number 2, performance goals to students to work towards. And number 3, I made building and testing a requirement in this project. I got students to build at least 3 prototypes and test them. Now, back to number 1. For the build criteria, I took these 3 suggestions from ChatGPT. Number 1, all boats must have a length that is 3 times longer or bigger than the width. Okay, so this is the number 1 suggestion that made a huge difference to the projects. This makes sense because most boats are not squares. You know, most boats are streamlined, all right? So students can't just make any raft or any bowl with tinfoil and just be done with it. They actually have to make something that is streamlined like this. Also, boats, according to this criteria, have to be at least 3 times longer than wider. Okay, they can actually be more than that. For example, if the length is 24, but the width is 6 for a ratio of 4:1, that is absolutely okay. And in fact, some students make even longer boats than 3:1 ratio. It's all good. It's all part of the testing process for students. Okay. Number 2, all boats, according to my criteria, must be made of 1 sheet of 12 by 12 foil. That's 12 inches by 12 inches. Okay, this foil can be cut up, it can be folded, it can be retaped, but the maximum amount of material is 12 inches by 12 inches, which is about the length of a ruler this way and that way. Now, students can use tape, but I told students that the tape can only be used to connect things and not to build walls themselves. Okay, and finally, number 3. Oh, wrong one. Number 3. I said that at least 25% of the length of the boat cannot be covered by pennies or marbles. Okay, so if you think about a large freighter that transports cargo around the world, The containers don't actually sit on every part of the top of the freighter. There are parts of the freighter where the containers don't stack. Likewise, students cannot stack marbles everywhere. They must build into their design 25% of the length where marbles don't reside. All right, so in this case, as you can see, marbles won't go here. The student kind of built it into there, but marbles will go here. On this design right here, let's go back to this one, they actually built little walls here to prevent marbles from going here and here, but the marbles will go dead center into here. All right? This is another one of those design things, design criteria, that really made a difference to how students built their boats. Okay, so that was number one, build criteria. Number two, let's talk about performance goals. I told students that I give marks for improvement between the first and second and first and third prototypes. Thus, if students only built one prototype, they can't get an improvement mark. I also tell students that I give a mark for how many marbles their final boats can hold before it takes on water. So a boat that can hold 90 marbles, at least 90 marbles, will get a 4 out of 4 or an extending. Okay? 65 marbles will be proficient, 45 will be developing, and 20 is emerging, or like level 1. Okay? So in fact, this past year, or just this past week, I actually had several students make boats that hold 100 marbles without sinking, okay? Which is a testament to their hard work in building and testing their ideas. Okay, so give this new version of the Aluminum Boat Challenge a try with your class. It's definitely been an upgrade, and this is thanks to AI. That's it for this episode. Please smash the like or subscribe button or leave a comment below. And handouts once again are at realsciencechallenge.com/EP81. Thanks for watching. And let's talk science education again soon.